topographic map shows the vicinity of Lake Wohlford. Outlined in green is the boundaries of the hydrologic subarea. Within this area, all precipitation flows into Lake Wohlford. The other inflow into Lake Wohlford approximately follows this north-south. Water flows from the San Luis Rey River. There's a flume, and that flume delivers 50 cubic feet per second into the Lake Wohlford Reservoir. Outlined in blue is our projected new elevation for the Wohlford Reservoir after the dam is raised and completed. In red, here at the west end of Lake Wohlford is the area of our new dam construction. That includes the site of the dam and also the construction staging area.
As you can see, Lake Wohlford is covered in a sandy, protected soil. For this project, the important parts of the geotechnical report was to determine what type of dams are using for this type of projects. Based on the subsurface soil, as the sand and other bedrock that we found in the SDS, we were able to determine that the best type of dam for this project was an RCC dam, based on its quick ability to be constructed, its life cycle of being over 100 years, and its small footprint, so less environmental impact.
Hi, my name is Chris Wiglowitz. I was on the Wohlf design team, and my contribution was the environmental impact report.
In producing the environmental impact report, there are some major issues that we encountered in providing mitigations to problems we incurred. First of all, the local area is surrounded by Native American tribes, and there was an issue in making sure that we accommodated their points of interest. If on our site we found that there were some artifacts or points of interest that were needed by the Indian tribes, construction would have to be halted, and those sites would need to be further investigated. Other issues were some of the biological elements of the project, some of the fauna and habitats of the area. At the site, there were issues with land reclaimment. Obviously, with a dam project, certain lands could not be returned to their natural habitat. Included in that dam project was increasing the volume of the lake and thus increasing the shoreline. This increase would take away native habitats along that shoreline that can never be returned to their natural state. Another issue with the increase in volume for the lake was the reclaimment of land currently being used by state and fish game and their fisheries, and also lake operations and recreations. Those sites would have to be moved farther out of the water boundary area in order to continue operations. Other issues that we incurred were noise and air pollution. With our RCC designed dam, we needed to have an on-site batch plant that needed to run continuously in order for the material to bond and set as desired. This gave us a problem with noise pollution and air pollution that needed to be mitigated through proper filtration techniques and noise codes.
For the structural stability portion of this project, we had to really include an earthquake analysis. Due to the current dam failing under a 7.0 magnitude earthquake or above, we had to make sure that the replacement dam was going to be feasible to hold that, plus a much greater magnitude earthquake than that responsible for the lowering of the lake. So the structural stability analysis we included overturning analysis, internal stress of uncracked sections, sliding stability, and in all three of those we included earthquake loading to make sure that our dam, our new replacement RCC dam, would be strong enough and more durable enough to withstand the elements that are here at Lake Wohlford. Hello, we are at the current Lake Wohlford Dam. As you can see, the hydraulic fill layer on top of the dam is what is planning on replacing it to be about 50 feet from the toe of the dam, and it would actually envelop the bend in this road, so this road would actually have to be moved. We are planning on also notching the current dam so that the replacement RCC dam would be able to feel full effect of the water being held against it, so that it would be a complete system.
Critical part of dam design is the spillway. The spillway must be capable of discharging all the water under maximum conditions. In this case, we previously determined it to be 18,400 cubic feet per second. Our dam, since we already decided on a roller compacted concrete dam, we had to design a spillway that would be able to discharge that amount of water. Referencing the United States Bureau of Reclamation manual for small dams, we decided that the OG type spillway would be best. An OG spillway is designed to have maximum efficiency in discharging water. Our final spillway design included a width of 100 feet and a depth from dam crest of 20 feet. We determined that 14 feet of head would be the discharge under maximum conditions.
My name is Mark Moreno. I do the strip and erosion control plan.
The basis of this design was to prevent any contaminated runoff coming from the designated construction laydown and on-site batch plant into the adjacent creek located here on the dam. To prevent this, we added gravel bags along the length here, followed by fiber rolls coming down the slope as seen in the topography map. We added fiber rolls along the road crossing the creek to provide also any contaminated runoff from going into the creek, followed by gravel bags and a silt fence. We provided a stabilized construction entrance at the entrance of the project to prevent any contaminated substances coming onto the project or coming off.
So the total cost for the replacement dam is going to be $19 million. The most expensive was the RCC material and labor, which pulls up to $12.5 million. Also, the batch plant was about $1 million. For the schedule, it's going to be about 15 months for the construction of the dam. The longest item is the actual placement of the RCC material, which will be 96 days. During the placement of the RCC material, those will be the longest working days on our job. There will be 2 shifts for the workers, and they will be working around the clock. So about 20 hours a day, they will be placing the material.
This is the final design of the replacement dam at Lake Wohlford, modeled in SolidWorks. As you can see, the spillway is 100 feet wide, thus giving us appropriate flow rate in maximum rain conditions. Also, you can see that the height of our dam is 120 feet tall from the subsurface soil level. This allows us to achieve a 30% additional volume to Lake Wohlford. The top elevation of the dam is at 1,510 feet.
We are Wohlf Design and we approve this message.